So this is amazing. Matsuura has really focused and done very well on 5-axis and automation. When I was talking with Katsu and the team about what they think about their company with regard to innovation and technology, and for them, they're also focused on this. And in fact, they've had this for technology for quite some time, but this is new to the American market, and it's amazing. They're doing a sintering technique where they're printing, say, 10 layers. Each layer is 0.5 millimeter, and then they're going to come in and they're going to machine it back down. And this is not an actual machine, it's just a replica of one. But what's really cool about this is that you're able to sinter with a laser, but the machine and the machine tool can stay basically ready to go. So as soon as this layer has been sintered, it can come over and do the machining that needs to happen and then hop right back. You don't have in the case of some other machines that we've seen, a relatively bulky head that has to get tool changed out. It takes quite a bit of time. So I think this was a number of maybe 9 hours here, and this was 40 hours. But they said you have a very reliable process. So basically it should always work. And what's amazing is the machine can detect if when it was doing the sinter, there was some sort of a problem, and it can machine that problem back down and start over on that layer. That's really cool. And so this example here, we see this was one where they did the machining, and this is where the one where they left it as just a 3D printed, just as a comparison. But this comes off, this is, I think they said, similar to an H13 tool steel. When it comes off, it's about 35 Rockwell. Putting it in an oven for 460 degrees C for, I think, 4 hours brings it up to 53 Rockwell. And this is the part. This is actually literally how it works. It doesn't fit because of the shrinkage from injection molding, but I mean, that is really cool. And they've got an example here of a mold along with the transparent sample that they 3D printed on another machine just to show the cooling loops through here. And so that's the trick. They're able to do some really complex geometries that can save you from having to do complex 5-axis work or sinker EDM work, but also just stuff that you could never otherwise do with those nested cooling loops. Same thing with this part right here. They've got a coolant channel going in and they've got it coming out, but instead of it just going straight across, it's actually able to loop up all the way through and really improve the cycle time of each mold. Same thing here, you've got 2 halves of a digital camera case. It's just so cool. Like, the surface finishes are beautiful. A relatively simple part, but nevertheless, you can see what that would look like. So here we go, like that. I think this one is just the coolest though. You know, they're able to do the machining at each level, so it's able to make otherwise really difficult or complex shapes like that.